Welcome to Easy Math TV. Here's another exciting video in our statistics series. We're going to talk about measures of center today of a data set. This is beginning chapter 3 in our textbook in our University of New England statistics class. But if you're just interested, you just happen to come along this video and you're just interested in how we do measures of center, especially in StatCrunch, you are on the right video. So we're going to start by talking about the mean. Whenever you have numeric data, so that a series of numbers, any list of numbers has a mean, and the mean is just the average. So here we have a sample of 16 wait times for a popular amusement park ride, taken at random times of the day and random days of the year. And we just kind of took a random sample of that. So the idea of the measure of center is that you want to know what is typical, like what is a typical wait time for amusement park ride. And so the mean is one of those ways of measuring. And what I want you to notice here is that I have these 16 numbers. And if you just want to hand calculate it, you would just add up all those numbers and then divide by the number of numbers, which is n. So sum up all the numbers and divide by n, which is 16. And according to this, we get 43.75. So I want to show you how we would have done that in StatCrunch. So in StatCrunch, we have access to data sets that are all included in our classroom activities. So we're going to go under data and we're going to go to load, and these are going to be shared data sets. And that's going to open up a window here. Now there's a whole bunch of data sets here, tons of them. So I'm just going to do a search on amusement park. And lo and behold, there's one with my name on it. So that's the one that you want to do because it's the 16 numbers that we had. There's our 16 numbers. And to calculate the mean, all we need to do is go under the stat menu and go to calculators. Oh, sorry, not calculators. Summary stats, and then go to columns. So var1 is our column, and notice that there's a bunch of statistics that we can calculate based on this data. And I can get both the mean, so that the mean is one of the measures of center. I'm going to hit the command key and scroll down. The other measure of center is the median. And if it applied, there would also be a mode if it exists. Otherwise, you're going to see that it doesn't. Maybe there isn't one. Okay, so we're going to just get all three of those just for the sake of doing it. Those are our three measures of center: mean, median, and mode, because they're all going to give us an idea of what is typical in this data set, okay? So I'm just going to go ahead and click compute. And up popped this window that said, in my column var1, variable 1, my mean is 43.75. My median was 35, and apparently there's more than one mode. So it just says multiple modes. And that just means that there is more than one value that appeared the most often. And if we actually take a look over here, you can actually see that here we have, this is actually sorted data too, so we can actually see the numbers in order. The number 30 appears 3 times, and the number 35 appears 3 times. So one way of telling that is that you can also go under data, under the stat menu, we could just create a frequency table of our data. And I'm just going to do frequency and even relative frequency and compute. So this is telling us how many of each of those wait times we had. And you can see that the 30 and the 35 both appear 3 times. All right. So that also, the mode gives you another kind of measure of center, like what is typical in our data. And then the median is 35 and the mean was 43.75. So when you put those three numbers together, you get an idea of where the center of your data is. So let's go back to our document. Okay, so now it says your turn. So what I would like you to do is open StatCrunch and look for the soccer players data. So you don't have to worry about the word semi-professional typing that in or anything. You're going to look for the data set that says soccer players. Okay, and you're going to load that data. And then I would like you to do the same thing that we just did. I want you to find the mean and the median and the mode of that data and write them down here. So you can actually put this into your notes. You don't need to list all of these numbers. They're just there for you to see, but we can get them into StatCrunch anyway, and you can copy and paste them out of StatCrunch if you want. So look for the soccer players data and calculate the mean, median, and mode after you saw how we did that with the amusement park wait times. So let's go back over to here and we're going to do that again. We're going to go to data, load, shared data sets, and I'm going to look for soccer players. Soccer players. There we have the one that has my name on it. Look for that one. So these are U.S. soccer players and their heights, semi-professionals. And this has been sorted. So these numbers are all sorted now. And there's 100 of them here. So like you've got 100 values. Okay. So kind of the same thing that we did with the other data. Let's go to stat and summary stats and columns. And we're going to choose the soccer player heights column. And then down here, I'm just going to do N too, so that we see that we have, it'll tell us that we have 100 values. And you're going to select multiple things. You're going to select the mean and then kind of use your scroll wheel on your mouse, select median. And I think you have to hit either the shift key or the control key to select multiple things. And then we're also going to get the mode. Okay, so those are the only things we want. And mean, median, and mode. Okay, and that's going to calculate those. So when the mean and the median and the mode are all about the same, we say that our data is roughly symmetric or normally distributed. So we have strong evidence here that our data is normally distributed because the mean and the median and the mode are all practically the same. We can get a better idea of that by going into, we can make like a little frequency table of our data. Frequency, and this time I am going to bin it. So we're going to bin the data this time because there's a lot of numbers. And let's hit compute. There we go. So we can see that the frequency table starts out small, gets big, and then it goes back to being small again. And we can even verify that by just looking at a quick histogram of this. I'm not even going to choose any options. I'm just going to say frequency. A histogram. So this histogram is basically symmetric. So the tallest column is right in the middle here. And then it gets shorter on both sides. Okay? So so you've got really good symmetric data here with the soccer player data. and you can report the mean and the median and the mode, and you can actually state that they are about the same. If the data had been skewed a bit, then you would see that the mean gets pulled to one side or the other by outliers. So had there been some outliers, they would have pulled the mean to one side or the other, and it explains it here too for you. So then in task 2, you're being asked to talk about the median a little bit. What was the median for the median wait time for the amusement park data, and you can write that number down. And then for task 3, the job here was to basically compare those two data sets. The amusement park ride data was, you're going to discover that that was skewed, that there was some skewness to it. The mean and the median are not at all the same, and that's because there were some outliers. So there's some takeaways here that are going to be really important for you. Like, so anytime we're examining data, we're going to be very concerned about whether it's symmetric or normally distributed versus skewed to the right or skewed to the left. That's going to be a really important thing to consider in the future. So looking at the mean and the median and comparing the two numbers together is a good way, is one way of determining whether your data is symmetric or not. Fact 1 is when the mean is different from the median, there's evidence that the data is skewed in the direction of the mean, away from the median. So either to the left or to the right. Fact number 2, when the mean, median, and mode are all basically the same, they don't have to be exactly the same, they just have to be relatively close to each other. Then there is evidence that the data is in fact bell-shaped and symmetric. So then answer these two questions if you can down here. How would you then describe the amusement park data? Would you say it's symmetric, skewed left, or skewed right? And how did you decide this? Simply from the mean and the median. And then how would you describe the US soccer player heights data? Is it symmetric, or is it skewed left, or is it skewed right? And how did you decide this? Simply from the mean, median, and mode. So I'm asking you to put your answers to those in your own words. And then task 4, the last thing that we were being asked to do is to talk about measures of center if we don't have the original data. Pretend we don't have the data itself, but we do have a binned frequency table. So in a binned frequency table, the way we calculate the mean is by taking the midpoint of each class. So this table here for the LA commute times, we had filled this in a previous class. This is our LA commute times data, and these are our bins, and then these are the midpoints in orange that you see here, and the frequencies are the counts, how many were in each thing. So in this column over here where it says midpoint times frequency, we're going to multiply the midpoint times the frequency and fill those numbers in. So essentially, this is what we need to do now with that. Let's look at I want you to be able to see this. So let's go to we did the 7 times 6 already. So let's do the 22 times 19. So 22 times 19 equals, and that's 418. Let's move that off to the side now. So that's going to go here, 418. And now we need 37 times 14. So 37 times 14 equals, and that's 518. So that's pretty big. 518. That one was orange. Okay, and then let's do the last bunch here. So 52 times 5. That's 260. Fill that in. 67 times 5. 67 times 5 equals 335. 335. And then we have an 82 times 1, which is 82. And then we have a 97 times 1, which is 97. So, whoops, 97. So those are our midpoint. We took the midpoint of each category and we multiplied by the frequencies. So we're kind of pretending that we did not have the original data to look at, okay? That's what we're doing. If all you have is a frequency table, how do you calculate the mean? So let's make that orange because I like to have everything matching. So if we add up all those numbers now, so let's add them all up. 42 plus 418 plus 518 plus 260 plus 335 plus 82 plus 97. So 1,752, and that goes in this line down here. So that is the sum of that column. I just did a column sum. And then over here, then this is going to be my mean. So n, the lowercase letter n, that is the sum of all of our frequencies, remember. So that's our sample size. The sample size was 51. So I'm going to take 1,752 and divide by 51. And let's round it to the nearest hundredth. So this is going to be 34.35. 34.35. So that is the, without having the actual data itself, if all you had was the binned frequency table, that is how you calculate, or you get an estimate. It actually is an estimate for the mean from a binned frequency table. So the claim then is, so like basically from the binned frequency table alone, we can estimate the mean. It's not the exact value, but we can estimate it. So using those calculations, we can also then, we already previously had figured out what the median and the mode were. So, so write down what your estimate is for the mean. And then in the previous exercise, we had found what the cumulative percentages were for this data. And we actually figured out what the median was, which is the 50th percentile. And what is that number? So basically, and then what is the mode? I think we can actually cheat and go into StatCrunch to get all of this too. So let's delete all of this. And we're going to load. Let's look for our commute times, LA commute times. Hopefully it's the same one. Oh, maybe I didn't have the word LA on it. It should have my name. Oh, let's look at my data sets. I guess maybe it's this one. Oh no, that's not it. That wasn't it. I guess I don't have the LA commute times data. So, okay, so we won't have to worry about that. But we did it in a previous class. So it's important that we actually do some comparison of the median and the mode with the mean that we just calculated. So, so then on your own, I would like you to try to come up with your own conclusion then about the LA commute times data. Was it symmetric and bell-shaped? Is it skewed left? Is it skewed right? And how can you tell? So again, the measures of center will tell us a lot about what is typical in our data, and it will also tell us a little bit about the shape of our data, like where the largest numbers tend to be concentrated, and then are there extra numbers that trail off to the left or to the right. So that is the whole point of section 3.1, and that is our learning activity for today. So like, subscribe, comment down below if you're enjoying these videos. If you find them useful, please share them with others, and I'll see you in the next video.